Hello friends, welcome to this video on inverse Laplace transform where we will be using partial fraction method to find the inverse Laplace of a given function. Partial fraction method is going to be one of the oldest method which can be used to resolve fractions. Now we will see how to apply them to solve inverse Laplace modes. Usually whenever we have fractions, your quantities can be of three different types. The first type where I can have factors which are going to be separable like s plus 1, s minus 3 in a case. This can be expressed as fraction as a by s plus 1 plus b by s minus 3. So you have factors which are going to be distinct and this can be separable in value. Say suppose the second quantity of type of fraction is you have repeated factors like s plus 1 the whole square into s minus 3. So the total power of s is going to be 3. So we require 3 fractions to solve this. In which case the unique quantity can be separated as a by s minus 3. But what happens here? S plus 1 repeats itself 2 times, in which case you will give one constant b for your s plus 1 and one more constant called as c for your s plus 1, the whole square. So whenever we have repeated factors, give one constant for each of the repeating factor. This is our type 2. Type 3. When we have a denominator which is non-factorizable, say suppose it's of the format s square plus 4. Now, I cannot split this by any way. If it is going to be s square minus 4, then I know a square minus b square can be split as a plus b into a minus b. So I can write this s square minus 4 as s plus 4 into s minus 4. But now what happens in this case? This is going to be s plus 2, s square minus 4 is s square plus 2. So s plus 2 into s minus 2. Now since this is s square plus 4 which is non-factorizable in nature, and if I have in addition to it some other component called as s plus 1 which is going to be unity, then what do we do is for the singleton quantity we assign a separate fraction, and for this factor which is non-factorizable, since it is going to be power 2, we assign the fraction to be of the format bs plus c. So this bs plus c take care of this non-factorizable factor over here. So this becomes s square plus 4 with the numerator as bs plus c. These are the three commonly occurring types of partial fraction in our engineering problems. So now we will see how to find inverse Laplace for functions of this kind when they appear. We will see them one by one. The first question, let us find what is going to be Laplace inverse of 1 divided by s minus 2 into s plus 3. As such, we will first consider the partial fraction s minus 2 into s plus 3. Since they are going to be factors which are independent, what I can do is I can assign separate variables to it as s minus 2 plus b by s plus 3. Now take LCM to your denominator, in which case s minus 2 into s plus 3 will be a times of what is missing here is s plus 3. So adjust it with s plus 3 in the numerator. What is missing in the second term is s minus 2. Adjust your b with your s minus 2 in the numerator. Now comparing your first term and the last term, both your denominators are the same, hence you can compare your numerators, in which case 1 is equal to a into s plus 3 plus b into s minus 2. Now, our motive is to find the values of a and the value of b. How to get it? Since these are going to be factor, I can just substitute if s plus 3 is a factor, s plus 3 is equal to 0. S will be equal to minus 3. So we will see on substituting s is equal to minus 3, what happens? When you substitute, you will have to substitute on both left hand side as well as right hand side. Left hand side has no s for substitution. So it remains as 1 with a times of this s gets now replaced as minus 3 plus b into minus 3 minus 2. Minus 3 plus 3 turns out to be 0. So you have 1 is equal to b times of minus 3 minus 2 makes it as minus 5. From here, I get the value of b to be equal to minus 1 by 5. Hence, I have got the value for the first constant. Now, how about the second constant? We have one more factor called as s minus 2. Equate that to 0. So, what we have is s is equal to 2. When I substitute s is equal to 2 in the above equation, what we will be having? I have 1 equal to a times of s plus 3 plus b times of s minus 2. The value I am substituting on both sides is s is equal to 2. So this gives me 1 is equal to a into 2 plus 3 plus b into 2 minus 2. 2 minus 2 vanishes, leaving you with a times of 5. Hence, a is equal to 1 by 5. Now, I have got the answers for both of my constants a and b. In which case, I now know 1 divided by s minus 2 into s plus 3 minus 2 into s plus 3, which we expressed as a by s minus 2 plus b by s plus 3, can now be rewritten of the format 1 by 5 times of s minus 2 plus what was the value for b? Minus 1 by 5. So, minus 1 by 5 times of s plus 3. So, this is my 1 by s minus 2 into s plus 3. Now, I have resolved it into partial fraction. Go back to your original question. What we wanted was Laplace inverse of this fraction. So, when I wanted apply Laplace inverse to this quantity, what do I do is take Laplace inverse on both sides. Hence, this gives me the value of Laplace inverse of 1 by 5 by s minus 2 plus Laplace inverse of minus 1 by 5 divided by s plus 3. 1 by 5 is a constant. It comes outside, leaving you with 1 by s minus 2. 1 by s minus 2's Laplace inverse is e to the power of, since it is minus, it is plus 2t. Minus 1 by 5 comes outside, leaving you with 1 by s plus 3. Since it is plus over here, e comes outside as minus 3t. Hence, the final answer is 1 by 5 times e power 2t minus e power minus 3t. Hence, I have computed the Laplace inverse of 1 by s minus 2 into s plus 3 using my partial fraction method. Now, let us apply one more example for my type 2. Consider the Laplace inverse of minus 3s squared plus 20s minus 27 by s minus 1 into s minus 2 the whole square. Now this I can write it as Laplace inverse of, I can split this into, total power of s is going to be 3, so into 3 factors. So I can make it as a by s minus 1. Since this is a repeated factor, I give two values for it. One is s minus 2 and the other one being c divided by s minus 2 the whole square. Now on comparing your numerator, I have minus 3s square plus 20s minus 27 to be equal to, take LCM. So you have a times s minus 1 is there, missing quantity is s minus 2 the whole square. B times of s minus 2 is there, s minus 1 and one more s minus 2 is missing over here. Plus c times of s minus 2 the whole square is there. Missing quantity is s minus 1. Now how to resolve this a, b and c? First, substitute s is equal to 1 on both sides. I will have minus 3 plus 20 times of s. So it is 1 minus 27 to be equal to a times of 1 minus 2 the whole square plus b times of 1 minus 1, 1 minus 2 plus c times of 1 minus 1. The c and b cancels off, leaving you with a to be equal to minus 10. Now in the second quantity, you put s to be equal to 2 because this is my factor. When I substitute s to be equal to 2, you will be getting your c as 1. So the second constant is also gone. Now how to get the third constant? You can compare the coefficients of s square on both sides. When I compare the coefficient of s square, what is it over here? You have it to be equal to minus 3. On the right hand side, this is going to be s square, the coefficient being a. And this gives me s into s square with the coefficient as b. C has just a s minus 1. It doesn't have an s square. So the coefficient is 0. So on comparing s square on both sides, the coefficients gives me minus 3 equal to a plus b. Already I know that a equal to minus 10. Minus 3 plus minus 10 will be equal to b. This gives me the value of b to be equal to 7. So put it back over here. In which case, what will happen over here will be, you will be left out with Laplace inverse of minus 10 divided by s minus 1 plus b was 7 divided by s minus 2 and c was 1 divided by s minus 2 the whole square. Now let us take Laplace inverse for each and every term. So this gives me minus 10 1 by s minus 1 is e power minus, so it is plus t. Take your 7 common outside. So this gives me 1 by s minus 2. Since it is minus, it is e to the power of 2t. This is s minus 2 the whole square. I have to push my s minus 2 to s first before applying Laplace. So this now comes outside as e power 2t, leaving you with Laplace inverse of 1 by s square. What is Laplace inverse of 1 by s square? It is nothing but our t. Hence, Laplace inverse of minus 3s square plus 20s minus 27 by s minus 1 into s minus 2 the whole square makes it as minus 10 e power t plus 7 e power 2t plus e power 2t times of t. Now, we will apply one more example to evaluate the third type of partial fraction. Consider the example of finding Laplace inverse of 1 by s squared plus 2s minus 3 into s squared plus 1. Now, as such, when we see this is going to be a quantity which is going to be factorizable in nature. So, how can I factorize this as? You can split this s square plus 2s minus 3. Sum is going to be 2, product equal to minus 3. So, I can split it as s minus 1 into s plus 3. So, this is my factorization of the first factor. And the second one is s square plus 1, which is non-factorizable in nature. So let me have it as such. So the total power over here in the denominator is 2, 3, 4. So I totally require 4 constants to evaluate this Laplace inverse. So how I can write this as? For the independent components, give independent variables like a by s minus 1 plus b by s plus 3. And how about the third quantity? It is s square plus 1, which is non-factorizable in nature. So we will be requiring 2 constants of the format cs plus d. So whenever it is non-factorizable, you make it as the format as plus b. So since already a and b have been substituted for, it gets the format cs plus d divided by s square plus 1. Now, consider the LCM of the quantities. You will have 1 on your numerator on the left hand side to be compared with the right hand side, which gives you a divided by missing factor is s plus 3 into s square plus 1 plus b times of missing factor is s minus 1 into s square plus 1, and you have this to be cs plus d into the missing factors are s minus 1 and s plus 3. Now you can substitute s to be equal to 1 because you have s minus 1. When you put s as 1, what will happen? Your b will vanish, your cs plus d will vanish, leaving you with a. And the value of a can be obtained as 1 by 8. When I substitute s to be equal to second factor, what is the second factor? S plus 3 is 0, so s will be equal to minus 3. When I substitute s as minus 3, so you will have s plus 3, this will vanish, s plus 3, this will vanish, only your b will be retained. Your b will be retained as minus 1 by 40. So in the next case, what will we do is, we will try to compare the coefficient and get the values for my c and d. Now, on comparing, what is going to be the maximum power over here? It is going to be 2, 3, 4. Okay. So, we will compare power 4 on both sides. Compare coefficient of s cube on both sides. When I compare s cube on both sides, you don't have an s cube over here. So, the coefficient will be equal to your 0. So, no coefficient. So, it will be 0. On your right hand side, s square into s, this is my s cube. So you will have it to be equal to a. S square into s, so you will have it to be equal to b. C as an s, there is a s here and a s here. S square into s, so you will have it to be equal to plus c. So I have a plus b plus c equal to 0 on comparing the coefficient of s cube. Already you know the value of a to be equal to 1 by 8 and b to be equal to minus 1 by 40. So this leaves you the value of c to be equal to minus 1 by 10. So I have obtained the third quantity also. A has been got, B has been got, and C has been got. Now the last term to be estimated is my D. How to get D? Okay, so D can be compared with the constants. Comparing constants on both sides. What is going to be the constant on my left hand side? This is going to be equal to 1. This will be equal to 3 into 1. This is my constant for my A. So this is going to be 3A minus 1 into 1. So it is minus 1 times of B as a constant. CS, this is minus 1 and 3 with S. C doesn't have a constant at all. When it comes to D, minus 1 plus 3, so that makes it as minus 3 times of D. So on comparing the constants on both sides, I have 1 equal to 3A minus B minus 3D. Already we know the value of A to be equal to 1 by 8 and B to be equal to minus 1 by 40. So this gives me the value of D as minus 1 by 5. Now I have got all the 4 constants involved in my inverse Laplace. Let me move and fix it in the problem. So this now gets converted as 1 divided by, so A was equal to 1 by 8. So 1 by 8 divided by S minus 1 plus, what was our B? B was minus 1 by 40 divided by S plus 3 plus C. What was our C? Minus 1 by 10 times of S plus D. What was our D? Minus 1 by 5 divided by S square plus 1. So, I have substituted all my A, B and C in my components. So, now it is time to consider the Laplace inverse. So, how to convert into Laplace inverse? Take the individual components 1 by 8 times Laplace inverse 1 by S minus 1 minus 1 by 40 Laplace inverse 1 by S plus 3 minus 1 by 10 Laplace inverse S by S square plus 1. The last term minus 1 by 5 Laplace inverse 1 by S square plus 1. Now it is just an easy task to compare it with the formulas which we have already studied and then get our final answer. So this makes it as 1 by 8 s minus 1 e to the power of minus means plus t. The next term will be equal to minus 1 by 40 times Laplace inverse of 1 by s plus 3. What is going to be my s plus 3? So this gives me e to the power of, so minus 3t, minus 1 by 10 times Laplace inverse of s by s square plus 1. S means it has to be cos. What is the constant? 1t. So minus 1 by 10 cos t, minus 1 by 5. Since it is a constant, this is going to be sine, and sine 1t. Numerator is also balanced. So I can directly write my answer to be equal to sine t. So this completes the Laplace inverse of the expression 1 by s square plus 2s minus 3 into s square plus 1. Thank you.